Welcome to Dig Deep, the mining podcast. In this podcast, we go deep into mining news, hot topics, and live interviews with mining professionals and leading figures in the mining industry. Introducing your host, Rob Tyson, founder and director of Mining International and Mining International Executive, a leading global mining recruitment and headhunting agency.
Hi, mining community. Welcome back to another episode of Dig Deep, the mining podcast. And today's guests are Patrick Thévoz, the co-founder and CEO of Flyability, and Michael Blake, who's the product manager at the company, who are a Swiss company dedicated to making the world's infrastructure safer and more efficient through innovative drone technology. The company has developed a cutting-edge solutions that enable safe and efficient data collection in inaccessible and dangerous environments like mining, serving over 1,500 customers worldwide. In today's episode, we're going to dive deep into the cutting-edge world of drone technology, especially obviously in the mining industry, with the team at Flyability. We're going to speak about the technical depth and real-world experience to the table, what their technology does, from the capabilities and limitations of Flyability's Ethos 3 drone and its growing adoption across mines worldwide. We're also going to unpack this technology in transforming underground inspections. We're also going to explore what it's like to, I suppose, deploy the drone on site, the kind of data it delivers, and how it fits into existing mining workflows. Plus, we're going to tackle the bigger picture, what drives mines to adopt these solutions and where this technology is heading next, including the role of AI and autonomy in mining's digital future. So Patrick, Michael, welcome to the podcast. How are you both doing?
Great, thank you so much. Really nice to be here.
Hi, thanks for having us.
Yeah, great. As I obviously mentioned in the introduction, obviously Patrick is the co-founder and Michael is the product manager for Flyability. So just wondered if you both can introduce yourselves, tell us a little bit about your careers, how you and then obviously how you got into the mining industry before we speak about the company and other questions around the drones and the technology. So I'll start with you, Patrick, first of all.
Sure. Yeah, it was pleasure. I'm an engineer by training. Unfortunately, couldn't really work as an engineer at any point in my career. Right after engineering school, I moved to consulting, like really driven by this idea of how do you take research and bring it to market. The consulting world was a little bit too much about building slides rather than doing it in the actual world. So the natural step for me was to do it in real life with Flyability and what has become Flyability. And the project really interestingly started with a PhD thesis in both Switzerland and in the US, looking at it was the time of Fukushima, Haiti earthquake. So, and it was the starting of this time when we were credibly looking at robots being able to go where it's too dangerous for humans to go. It was a lot of difficulties for current robots to be able to enter the very complex spaces, such as the Fukushima power plant, for instance, because a ground robot cannot access this place because there's a lot of debris, there's a lot of you need to be able to climb upstairs or destroy stairs, etc. And drones are really made to fly outdoors, in wide open spaces where you would expect a drone to fly. And it's really by looking at how insects solve the challenge of flying indoors, which is a combination of a lot of things. But first of all, they are very tolerant to collisions. I mean, you look at a housefly, typically, it will bump on the obstacles that it cannot detect until it finds the opening and goes out. And this is the very first thing we try to replicate with our early prototypes in 2013, a collision-tolerant drone made for confined spaces, places, lots of obstacles. Originally was this vision of we're going to be developing very much search and rescue tools for the Fukushimas of this world. Very quickly realized that it was not the best and the most repeatable business model, and within the first weeks of us starting talking about this about the prototype, exploring the market, we got very viral, and a lot of people started calling in and saying, "Hey, I've got this problem. Could it help me? Could your prototype help me solve it?" Most of them were already in industrial settings. People that needed to inspect bridges or power plants or any sort of industrial sites. And since this day, a couple weeks after we started the company, we've been solely dedicated to this mission of making the world's infrastructure safer, more efficient, using robotics and sending those robots instead of humans in those risky environments.
And Michael, why don't you just tell us a little bit about your career and your background?
Yeah, so actually similar to Patrick, I also come from an engineering background, but more on the architectural and structural engineering front. But during my time in college, actually, I had a summer job working in Lisheen Mine, which is actually one of the richest zinc mines in the world, based in Ireland. So quite lucky to have the opportunity. From then there, when I finished my degree, the mine actually kept me on as a junior engineer, working mainly on doing structural assessment and also maintenance prevention as well. From there, I also did my UT qualification too, so ultrasonic technician. But actually, one day a company came to the mine to fly a drone over the mine. So this is early day drones, maybe 12, 13 years ago. It was like a CS for Brammer, civilianized flying wing, amazing thing. I was totally hooked from then on. My background also as a hobby is I fly model airplanes and helicopters internationally for competing on indoors and outdoors as well. So then I joined this company to fly drones, trained up as a topographical surveyor. And then from there, actually, I started building drones in my shed back home. So very, very early day drones, buying fuselages, wings, motors, Pixhawk autopilots at the time, with Sony cameras inside and getting everything to fly all at once, with a bit of trial and error, as you can imagine. But from then there, I kind of advertised myself a little bit on LinkedIn to what I was doing. And another Swiss company, also from the EPFL as well, that Flyability is from, called SenseFly. They picked up my profile, and I moved over to Switzerland to work with them. So I was with SenseFly, who build flying mapping wings, so about meter wingspan with cameras inside. It's very similar to what I was doing back home. And then from there, actually, the last 2 years now, I've been working with Flyability and looking after the product range, especially on the survey side, the LiDAR mapping, also the photogrammetry elements that we're implementing too. And yeah, it's been a really nice journey so far, and looking forward to the rest of the conversation.
Yeah, and I like hearing that your passion and your hobby is also your work. So it may not necessarily mean you're working, because it is your passion and your hobby, which is good to hear.
Absolutely, yeah, for sure. When I first came and started working this, I didn't feel like almost as work. The 9 to 5 wasn't really there. I was working all the time, doing even stuff at home as well to try to perfect the drones. It was just pure passion at that time.
Yeah. Patrick, one of you can just give us a snapshot of Flyability and the business as a whole.
Yep. So when we started building those machines for indoor confined complex spaces, nobody had ever heard of it, and so we're really pioneers, and by far the market leaders in flying in those environments where no other machine can reliably go. We started the business as a pure pure robotics play, a pure hardware play, and gradually we started adding more and more sensors on board the machine. It started just with a visual video camera, basically. And today, we are flying a broad range of instruments on board this machine, including lidars, thermal cameras, ultrasonic thickness sensors, radiation sensors, gas sensors, etc. So we really went from building one drone to providing a broad range of solutions, and developing a ton of software that goes in combination with this data acquisition towards providing end-to-end solutions to the various types of customers that we have, and providing insights rather than drones. Originally, our USP, our strength was being able to fly in those areas, and we found our markets in mostly power generation and oil and gas. Those were the big markets. That's interestingly, we serve both directly with the asset owners, work with Chevron, Shell, Exxon, whatnot, but also a lot with inspection companies. So companies that typically provide service, they can be big, they can be small. Sometimes it's a one-man operation, sometimes it's a multinational company that do provide service to those end customers, and we really have those two sides of the business. That in the end of the day, they do the same thing, but they've got very different realities in terms of what matters to them. The end users, the asset owners, they are the ones doing the big savings when we can, first of all, reduce downtime of their assets, when we cut down on the inspection costs because we can remove the need for scaffolding, and most importantly, as we increase the safety for their workers, because we remove completely the need to send people inside the dangerous confined spaces for any inspection task. More recently, as we have added this broad range of payloads, we started getting traction from other markets. First of all, in infrastructure, in water infrastructure, that was something super interesting to us, because there's obviously not so many nuclear power plants around the world, but there's a lot of sewer systems around the world, and we're increasingly getting a lot of success there, being able to detect, to map sometimes centuries old, that's no blueprint anymore. And in mining, which is I would say a newer market now, 3 years since it started to become a very, very meaningful market, and today the largest market we serve. It all came to this moment where we moved from visual inspection to really using and providing data associated with 3D models, a very accurate survey grade models that we're building. And mining is an important industry for us, because in most of the energy work, it's about doing an inspection, right? So you inspect your asset, depend on mostly the regulations and the age of your plants. Could be every 5 years, could be every year. But the use cases we have in mining, we have most of our customers using it day in and day out. It is really used as part of the day-to-day operations, which is why this market is growing so fast and became the largest one for us.
Yeah. So, yeah, if you can just tell us a little bit about the drone.
Okay, so the Elios 3 is a quadcopter configuration. I have one here in front of me. So you can see that the drone itself has a carbon fiber chassis and also a cage. So this actually makes the drone very, very strong in terms of collision tolerance, etc. For instance, we also have a UT payload that can attach to the drone, and that's a contactable payload. So you can actually fly the drone into a piece of steel, hold the drone against the steel, and measure the thickness. In terms of the flyability then, we have 16,000 lumens of light on the LED panels on the front. We have a 4K camera module as well as thermal module on the front of the drone. We also have visual odometry that we use for stabilization on the drone. And secondly, also, what is the big factor for mining is that we have a LiDAR on the rear of the drone itself. So the accuracy of the LiDAR is plus or minus 6 millimeters, 1 sigma value. And also we can get over 1 million points per second. So we can create an extremely dense point cloud, which is primarily used a lot in the mining scene for flying inside stopes, inside galleries, areas where miners can't access. Actually, we can use a drone to access and fly these areas and map these areas that were never able to be mapped before. On top of that as well, to create an even more high accuracy LiDAR model, we also plus process in Faro Connect software. So Faro, one of our partnerships that we work with quite closely, they have developed another SLAM algorithm software that we use then to be able to process the data from the drone and create a very, very high dense map as well. In terms of the flight time, the drone has 9 minutes of flight time, and now with the release of our bigger battery, which we have here, we can get up to almost 14 minutes of flight time, obviously depending on the air pressure and also the altitude that you fly. So it's used quite a lot as I said already, in the survey side of the mining, also from the visual inspection side too, for things like looking at cracks, hang-ups, etc. inside ore passes. It's used quite extensively. But mainly the main let's say area that the drone is used in mining is for the survey side, for doing volumetrics, cut and fill, fragmentation monitoring, also doing progressive monitoring as well of the mine, how the mine is being mapped, etc. Also compliancy as well, to see that the mine itself is being dug or being built to the specifications that was laid out previously in the mine progressive mapping. And also sometimes monitoring equipment as well. So we've underground crushers, underground conveyor belts, etc. So the drone itself is used quite extensively on the visual side, especially for those elements.
Yeah. I just wonder if you can just tell us a little bit about the Elios 3 and its, I suppose, usability in the mining sector, maybe some of the solutions it does provide, with obviously some of the challenges that might have, and also its limitations as well.
Yeah, so the drone itself is used quite extensively, mainly in the underground sector. For this, as explained already, it's used a lot on the survey side, also the visual side. But in terms of some customers that we have customers flying in, let's say, South America, in Chile, Argentina, at very, very high altitudes, up to 4,000, 4,500 meters. Also, we have drones underground quite deep as well. For example, in Kidd Mine in Canada, that we have drones flying almost 3 kilometers under the earth. So it's quite an extensively used product in different altitudes, etc. Also, for example, in Palabora Mine in South Africa, we have 3 drones there that actually never leave underground as well. They're working constantly underground. The main application for them actually is shock reading. So they would like to fly an area and map an area of the mine. And then after they do a shock reading, they want to do a shock reading inspection, so visual inspection, also LiDAR inspection as well, to understand the thickness of the shock read, to make sure it's compliant enough, but also not overly thick as well, that they're losing a lot of money in the shock read material. As you know, it's quite expensive. So these are kind of some of the applications that's being used underground, but mainly from the survey side, let's say, doing cutting fill inspections, fragmentation monitoring, volumes, etc.
Is anyone using your technology and obviously the drone in mines currently, or are you still in the sort of testing phase?
No, it is indeed massively used globally. So our biggest regions are definitely Canada, South Africa, and Sub-Saharan Africa. Latin America and Australia. So this is where we have most of our activities. But we really have hundreds of customers today in global across all markets. Approximately 1,500 customers. In mining, it's probably around 50 to 60 a day. We have published a lot of very interesting case studies, for example, with ICL Bowlby, about the work we did in the only in the only polyhalite mine in the world, and as well some very interesting work that we did with Glencore kids at a site that has the particularity of being 10,000 feet below sea level. It's a copper and zinc site. So yeah, it's really used majorly. All the largest mining companies in Australia have used or are using Elios drones as of today, and all major underground mines in sub-Saharan Africa also users of our technology.
Great. If we look from a more practical sense, let's say that you arrived on site with the drone. How does it start? How is it used? What's the process? How much training is involved?
Yeah, so usually when we arrive on site, after doing all the induction, etc., they go underground. Either we're taking a lift underground or driving underground if it is available. From then there, we usually arrive to the stope or to the ore pass or to the gallery that we're going to map. The drone itself takes around 5 minutes to set up. It's very, very fast. From then there, after we've done the initialization, we set up the program on our tablets. We have a flying application called Cockpit on Android-based tablets. Once that's all set up and ready to go, we're able to fly. So we can also select which battery we want to use. Mostly in the mining scene now, they're probably going to migrate to the bigger battery to allow themselves more flight time inside the areas. We've also now introduced as well into the drone RTS and RTH as well. So RTS is return to signal. So in some cases where miners are flying the drone down along galleries, etc., or up into risers, if they lose signal to the drone itself will fly actually backwards through its trajectory again to regain signal with the controller. If all signal is lost, or the battery gets low, or if the operator triggers it, there's also return to home. So return to home is our newest automation feature that we've now developed, which allows the drone to fly back and pick its own trajectory to get back home as safely as possible. So this allows, especially in the mining scene, to maximize the amount of flight time inside these different assets that customers are flying, and not have to worry about actually making sure the drone returns itself. In terms of the gallery data, as we explained already, it takes roughly between 1 to 3 flights to gather enough data on the ground in terms of a shift. Most of the shifts are roughly around 8 hours or so on the ground. So really, we're really focusing the drone on the mapping side on the ground and the inspection side to make sure that we can get all the data gathered within one shift or so, and processed as well. In terms of the training, the drone itself is actually quite simple to operate. It's similar to any outdoor drone that we fly indoors as well. We're using the LiDAR and the visual odometry to create a stable environment for the drone to fly, because obviously we don't have GPS on the ground. So we're using those two elements of the drone to make sure the drone is perfectly stable on the ground. So it almost acts as if it's an outdoor drone, but indoors. And then from there, once we come above, back on the surface, or even still underground, we can export the data from the drone into our own software called Inspector. The Inspector then allows us then to visualize from the camera information, and also visualize the LiDAR and also the drone itself inside the asset. From then there, we can export the data from Inspector for our technology software for doing a more high accuracy post-processing. We can also bring it into different third-party softwares like MapTech, like a Cyclone, 3DR, etc., to then do different types of calculations from the data. So as I said already, the volumetric calculations, progressive mapping, fragmentation, looking at the rock size, make sure that it can fit inside the crusher. Convergence monitoring, which is actually becoming a big hot topic for us as well, where customers want to fly inside an area or fly down an ore pass and look to see if it's changing in size, the geometry throughout months and years. Equipment checks, and also then some general surveying.
For companies that are not using drones at the moment, what's the tipping point that makes people go for a solution like this?
So the value we provide to customers is really, safety, efficiency, and cost reduction. So it's how do the companies value, and how much can we impact those 3 factors. that impact the speed of decision. And then there's a certain number of limitations. So we are, well, first of all, we focus really on underground mining, where this confined and complex space component is very present. And the more confined it is, the more we are the only solution out there that can gather data. So it's really a combination of that, which means that usually larger sites are the earlier adopters because of the sheer scale of the return on investment that they can do. And then it's very much of a matter of how much safety is valued by the operator. In some regions of the world, it is not as developed as in some other regions. And so for us, a large mine owned by a company with high safety standard, usually it becomes very much of a no-brainer for them to adopt once we've been able to demonstrate the technology. And this is usually what this tipping point is, this moment we walk on their site with the machine and do this first demonstration, and it's usually the eureka moment that leads to the first contact and the adoption of the technology, really.
As obviously technology is evolving at alarming rates, where is technology going from your point of view? And are you going to look at involving AI or anything similar into your product?
Yeah, it is really at the heart of what we're doing right now. There's this amazing moment happening right now in robotics, this convergence between what AI is able to do and giving them the ability to interact with the real world and gather data in the real world that robotics can bring. So both of them working together are opening endless possibilities. We're doing one of the big challenges flying in those indoor confined spaces is to have situational awareness of where you are, where you have no GPS, no other methods can be reliably giving you your localization. With all our algorithms and the fusion of the laser scans, the inertial sensors, the visual sensors, we're able to build this trajectory to automate flights. And this is where AI comes in as a way to, first of all, define autonomously the missions that the machine should perform during the mission, and at the end of the mission, to be able to draw insights from the data that was captured, and also from the data that was captured at different times, making a differential analysis of what was there 2 weeks ago, what is there this week. So everything linked to autonomy, both from this flight standpoint. For example, a feature we launched a few months ago is called Smart Return to Home, and it's this ability of the drone to at any point understand what is the shortest path to its starting point, understand how much battery it has left, and when the battery left corresponds to the amount of battery it would take to come back to the starting point, it triggers this autonomously. So really giving the user a lot of ease of mind, where he can change the battery and just press a button and it goes back to where it was before the battery needed to be changed. So this is just a small example of those increasingly autonomous features that will end in the press of a button that triggers a complete reporting on the site that is being surveyed, monitored, or inspected. And it is increasingly going fast with AI, in the sense that we are able to deploy solutions much faster, rather than developing use case by use case, something very specific. The deployment we're doing with AI allows us to be more generic and faster to market in a greater number of use cases at the same time. Maybe Mike, you have a few things to add on that.
Yeah, so one of the main aspects that we're looking at on the ground or on the surface as well, especially from a survey point of view, is to really refine the workflow as much as possible. As I said previously, a lot of these survey miners are working on a shift-based timeline. So we really want to make sure that all the workflow between flying the drone, processing, getting the analysis for the survey side, it can really be condensed and to be as efficient as possible. So for this, we're actually building in different elements into our inspector software in terms of different high accuracy SLAM, different survey elements from that to really make sure that we can get the data as efficiently as possible in the future. Secondly, on top of that as well, we're building our autonomous flight blocks as well. So that means we're looking at different automation on the drone itself for doing different aspects on the ground. Mainly the most exciting part of this for survey underground and mining is exploration. So the drone itself to be able to take off and fly into an ore pass, into a stope, etc. And for itself to compute and calculate the maps and make sure that we've enough overlap, density, etc. So flying the drone manually will probably become less and less in the future. And it's going to really optimize and make the whole workflow way more efficient on the ground in that case. Especially on top of that too, then we're working on colorization, which is probably one of our hot topics at the moment for release hopefully this year. So be able to colorize the point clouds and also make mesh models and colorize mesh models or project images onto the mesh. So this allows way more texturization on the ground and also for geology as well. It's one thing that we're really focusing in the future, the geology side, be able to do geology directly from the drone data itself. So not just on the survey side, but also the geologists as well will be able to benefit from different features coming in the future.
And and as a business, what's the outlook for the next 12 to 18 months for Flyability?
We're really just barely scraping the surface of what can be done. We estimate we're across all of our use cases, we're probably 1% of what could be done with this technology that is done currently. So growth, getting understanding and the customer needs in each of our different markets to develop those integrated solutions that then accelerate the adoption. As Mike said, having the partnership with the right software providers that our customers already use, developing automation workflows that allow them to deploy the machines without having heavily trained operators or anything like that, lowering the barrier of adoption. That's what we have been doing throughout the iterative product developments that led to the product we have today. I think this and this AI and robotics convergence that I was mentioning are really what we're putting our whole focus on.
And lastly, I wondered if there was anything else that you would like to add. Maybe some of our listeners maybe not even using drones at the moment, or they may be using drones that they may want extra features or want a better drone. I just wondered if you'd like to add anything else for more information for our audience.
Right. I mean, regarding the drones and the features, it's really again, it's really not about the drones, about what you need to gather and can you gather it with any other method. In our case, we've got this ability to gather data from places where no other machine can usually gather data. So we're very much not often in competition with other players, because if you can use other players, then you probably should. Which could be people walking around with serving tools, could be crawlers, but in many cases it's pretty much the only way, and so that's what most of our customers are doing. I think it might be interesting if Mike, you could go through a description of a few of our use cases or success cases in particular areas.
You got any stories to share today?
So from the case studies point of view, and some of the mining companies we worked with before, we've done quite a lot of collaboration with different companies. However, some standout key things was an ore pass block. So we had a huge hang up inside an ore pass. It was almost impossible to find this big blockage inside the ore pass. They tried different traditional methods like putting cameras down, boring in, putting CMS devices in to try and find this blockage. However, with the drone, within 2 flights, we were able to completely localize the blockage. So fly from the top of an ore pass down, from the bottom of ore pass up, join the maps together and actually see exactly where this hang up was inside the ore pass. So from then there, we could localize it, put it into the mine model itself. They could actually then drill into this section of ore pass and put explosive in and blow the blockage. And then from then there, the mine was able to start running again after almost 2 months of downtime. Second, also we do a lot of work as well with ICL Bulby. From them, actually, the drone now is actually making the whole mine almost compliant. So they've actually changed their survey methods on the ground to go from terrestrial style laser scanning now to only use the drone. So they're actually now qualifying the quality of the mining, the as-built model of the mine, the compliancy of the mining based totally now on the drone data allows them way more flexibility in their workflow for surveying. Also speed and efficiency as well. The mine, they're 1.6 kilometers down. It's almost 40 degrees of heat as well. So the less time they can spend underground, the better for them as well. So these are some of the things that a lot of customers are using the drone for, and some of the companies we're working with as well.
Thank you, Patrick and Michael, for telling us all about Flyability, telling us about obviously the drone technology that you're developing and the use cases that can be used obviously in the mining industry. If our audience wants to reach out to you, if they've got any questions, how can they go about doing that, and what social media channels are you on?
Yep. So we're on our social media. You can find us on LinkedIn, on X, on Facebook under the handle Flyability or variations of it. Just Google it. Website's www.flyability.com, and you can reach out to us at info@flyability.com. Happy to answer any question, and definitely interested in exploring new use cases, new application. We find those all the time, and I'm sure there's still a lot more to discover in the mining industry for us.
Yeah, certainly. All those details will be in the show notes that accompany this podcast for easy access for our listeners to reach out to you. So thank you again. All the best for the future. And look forward to obviously further developments on the drone.
Thank you, Rob. Thank you very much for having us.
Yeah, no worries. Thank you for listening. Hope you enjoyed that episode. As always, appreciate your continued support. Please keep sharing these episodes far and wide. This obviously episode was around drone technology and something that's, I think, going to become an increasing use in our industry. So appreciate if you can share this episode to other colleagues in the industry around the world to educate them on some new technology that Flyability are developing. Thank you again, and until next time, happy mining.
Thank you for listening. Remember to reach out to Rob via the show notes, and be sure to subscribe and leave a review. Until next time, happy mining, helping each other to improve the mining industry.